All right, here's the Quizizz review for you guys. All right, read the question. When we take a census, we attempt to collect data from. And the correct answer is every individual in the population. Censuses do that. They collect data from every person that you're trying to get data from. And obviously that is very hard to do. So typically they're not done in the United States, they're done once every 10 years. So it's going to be C. Number 2, a study of treatments for angina, not sure which one that is, pain due to low blood supply to the heart, compared bypass surgery, angioplasty, and use of drugs. The study looked at the medical records of thousands of angina patients whose doctors had chosen one of these treatments. It found that the average survival time of patients was given drugs was the highest. What do you conclude? So this is a study of medical records, not an experiment. So we can't make a conclusion that drugs prolong life. We can say tends to be that people who have taken drugs have a longer life, but we can't say they prolong the life because there could be other factors, okay? So this is an observational study. So the best we can do is maybe make a correlation, but we can't determine cause and effect. So that's going to be D. We cannot conclude that drugs prolong life because the groups might differ in ways besides the treatment. Maybe these people are just healthier. Tanya wanted to estimate the average amount of time that students at her school spend on Facebook each day. She gets an alphabetical roster of students in the school from the registrar's office and numbers of students from 1 to 1,137. She surveys those 30 students about their Facebook use. Tanya's sample is a simple random sample because, well, if you look up definition of simple random sample, it is any sample of size n, in this case 30, from a larger population. Any possible combination of those samples can be taken. So a simple random sample, every possible sample of size 30 has an equal chance to be selected. Now, some of you might think B is correct as well. Every individual has the same chance of being selected, but that doesn't define the simple random sample. A simple random sample's definition is every possible sample of whatever size you're looking for has an equal chance of being selected. So the wording does matter on that. Next question. Consider an experiment to investigate the effectiveness of different insecticides in controlling pests and their impact on the productivity of tomato plants. What is the best reason for randomly assigning treatment levels, spraying or not spraying, to the experimental units? We want to randomly assign so that way we can kind of average out any uncontrollable factors, things that might cause something to change. And if we randomly assign, we can have all those uncontrollable factors kind of spread out, okay? So random assignment doesn't help eliminate the effects. It doesn't eliminate at all. I mean, sometimes you're going to have effects of other variables, so it's not going to be A. It doesn't eliminate chance variation in the responses. Sometimes there's variation, and random assignment doesn't do that. Random assignment allows researchers to generalize conclusions about the effectiveness of the insecticides to all farms. If you chose this, you might be confusing random assignment with random selection. Randomly selecting farms from a larger group of farms and doing this study might help you conclude to all farms. But in this case, the farm wasn't randomly selected, so it's not going to be that one. Random assignment will average out other uncontrollable factors such as soil fertility, so they're not confounded with the treatment. And really, you want to do random assignment to help determine cause and effect, and we want to eliminate confounding to help you do that. And the last one, random assignment, helps avoid bias due to the placebo effect. Well, we use bias for surveys. We tend to use confounding for experiments. So it's not going to be that, because this is an experiment. Confounding is what causes those differences. Researchers randomly selected 1,700 people from Canada and rated the happiness of each person. 10 years later, the researchers followed up with each person and found that people who were initially rated as happy were less likely to have a heart problem. Which of the following is the most appropriate conclusion based on the study? Happiness causes better heart health for all people. Happiness causes better heart health for Canadians. Happiness causes better heart health for the 1,700 people in the study. So let's take a look at these three first. This is a study, not an experiment. There was no experiment. We didn't give people prescribed happiness, whatever that is, and then looked at their heart health. So we can't determine a cause and effect because it's not an experiment. We can see a relationship. So we can say happier people tend to have less heart problems. So now it becomes, well, do we say happier people in Canada are less likely to have heart problems, or happier people in the study were less likely to have heart problems? Well, we already know E is true. Happier people in the study were less likely to have heart problems. But because we randomly selected from a larger population, in this case Canada, we can make that conclusion to the population. So happier people in Canada are less likely to have heart problems because we have randomly selected. Yay, random selection helps us make inferences to a larger population. And it says so right here. Your population is all the people in Canada. Your sample is the 1,700 people you randomly selected. The sales force for a publishing company is constantly on the road trying to sell books. As a result, each salesperson accumulates many travel-related expenses that he or she changes to a company-issued credit card. To prevent fraud, management hires an outside company to audit a sample of these expenses. For each salesperson, the auditor prints out the credit card statements for an entire year, randomly chooses one of the first 20 expenses to examine, and then examines every 20th expense from that point on. Which type of sampling method is the auditor using for each salesperson? Well, let's take a look at what's going on here. Randomly chooses one of the first 20 expenses, and then examines every 20th. That's a systematic, all right? That's when you pick one, you count, you pick another one, you count, you pick another one, and you go every certain amount periodically. That's a systematic. Convenience is when you go up to people and say, hey, let me examine this stuff. Simple random sample, that's when you get everybody from a hat or computer program and you select a certain amount based off the random number. Stratified is when you get groups that are together, and then you sample from each type of group that have similar characteristics. And then a cluster is when you have you randomly sample an area and sample the people around it. Systematic is you pick one, you count every certain amount. This is going to say this is wrong. Your textbook says it's convenience, but I promise you it is not convenience. It is systematic. So pick E, that's the right answer. You'll be fine. Next question. Bias in a sampling method. Bias in a sampling method. Let me read to you a little excerpt from page 252 in your textbook. The design of a statistical study shows bias if it is very likely to underestimate or very likely to overestimate the value you want to know. So let's think about that. It's very likely to overestimate or underestimate a value you want to know. Using a method that favors a certain outcome will get you bias. So any difference between the sample result and the truth about the population isn't bias because it doesn't talk about the sampling technique you used. B, the difference between the sample result and the truth about the population due to using chance to select a sample. Chance is a good thing, okay? We want chance. Sure, chance might cause differences in the sample result from the population, but that's not a biased way of sampling. We want to use random sampling, so it's not going to be that. Any difference between the sample result and the truth about the population due to practical difficulties, such as contacting subjects selected. Well, that's not bias. That just might be like under coverage or anything that is out of your control is not bias. Out of your control is not bias. Now, if you are in control of this, then it could cause bias if your difference is off from the truth about the population. So look at letter D. Any difference between the sample result and the truth about the population that tends to occur in the same direction whenever you use this sampling method. All right, if you sample a certain way and you're getting differences because of your sampling, then that is going to give you bias. And finally, racism or sexism on the part of those who take the sample. Well, that's just a very specific, that's not broad, that's not generalizing. So it's going to be D. You wonder if TV ads are more effective when they are longer or reported more often, or both. So you design an experiment. You prepare 30-second and 60-second ads for a camera. Your subjects all watch the same TV program, but you assign them at random to 4 groups. One group sees the 30-second ad once during the program. Another sees it 3 times. The third group sees the 60-second ad once, and the last group sees the 60-second ad 3 times. You ask all subjects how likely they are to buy the camera. Which of the following best describes the design of the experiment? So A, this is a randomized block design, but not a matched pairs design. A block would be if you group the people according to certain characteristics of those people. And it doesn't appear that there was any blocking, okay? So we're not grouping by characteristics, which is what this would be. So it can't be that. And also a matched pairs design, remember, is a type of blocking where you're grouping each person and showing them different treatments and then comparing the differences. This is not happening because each person is only receiving one treatment. And it's going to either be the type of ad and how long the ad's going to be, or the amount of times the ad's shown and how long that ad is. So this is a completely randomized design. Now let's talk about the variables, because I think this can be confusing. You have 2 variables in this design. You have the time, and you have the number times shown. And you have 4 different groups, right? You have the time, which is 30 seconds versus 60 seconds. And then you have the number shown, which is either going to be once or 3 times. So you have 4 groups, call them A, B, C, D, but the variables are the time and the number of times shown. So it's going to have 2 explanatory variables in this case. 2 explanatory variables. All these individual groups, those 4 groups, are the treatments, not the variables. Variables are the time and the number of times shown. Can texting make you healthier? Researchers randomly assigned 700 Australian adults to either receive usual healthcare or usual healthcare plus automated text messages with positive messages, such as walking is cheap. It can be done almost anywhere. All you need is comfortable shoes and clothing. The group that received the text messages showed a statistically significant increase in physical activity. What is the meaning of statistically significant in this context? Statistically significant is looking at seeing differences that are out of the ordinary. Not necessarily very large or greater than 0 or generalizing it to a population, but looking at a difference that's above and beyond what you would expect just by chance alone. And so it's going to be E. The difference in physical activity for the two groups is larger than the difference that could be expected to happen by chance alone, because there's going to be differences. But statistically significant is seeing if those differences are worth thinking about, are worth analyzing and diving in deeper. That's statistically significant. When you look at the data and like, huh, that's way more than it should be. Last question. You want to know the opinions of American high school teachers on the issue of establishing a national proficiency test as a prerequisite for graduation from high school. You obtain a list of all high school teachers belonging to the National Education Association, the country's largest teachers union, and mail a survey to a random sample of 2,500 teachers. In all, 1,347 of the teachers returned the survey. Of those who responded, 32% say they favor some kind of national proficiency test. Which of the following statements about this situation is true? A, because random sampling was used, we can feel confident that the percent of all American high school teachers who would say they favor a national proficiency test is close to 32%. No, we don't have that confidence. This is a sample. We didn't get all the results back. B, we cannot trust these results because the survey was mailed. Only survey results from face-to-face interviews are considered valid. Well, you can't interview everybody, so it's not about trusting it. It's just not, it's being skeptical. And there's a difference between not trusting something and being skeptical of the results. C, because over half of those who were mailed the survey actually responded, we can feel fairly confident that the actual percent of all American high school teachers who would say they favor a national proficiency test is close to 32%. We can't be fairly confident because that's actually still a pretty small percentage of teachers that responded. D, the results of the survey may be affected by undercoverage and non-response, which is true, but I'll get to why E is wrong. The results of the survey cannot be trusted due to voluntary response bias. I mean, this is the only way to do this in this case is a voluntary response. You're gonna have to use voluntary response sometimes, but that doesn't mean we can't trust the results. What it means is we have to be skeptical of the results. The results of the survey may be affected by undercoverage and non-response. Undercoverage is when you don't reach all the people in the population all the types of people in the population that you want. And non-response is you're not getting enough people to respond back. So because of this small response and maybe not reaching everyone, you're gonna have undercoverage and non-response. So it's gonna affect the numbers. So it might be 32, it might be more, it might be less, we don't know. We can't be confident it's going to be close to 32, but we can't just dismiss the numbers. It's a survey, you conducted this survey, so we're going to pick this one. It may be affected by undercoverage. And this one is supposed to be systematic random sampling. I have to fix that on my end. All right, thank you for watching. I hope this was helpful.